Hi, welcome to Mathematics with Tom. I am Tom, and today we're going to continue. We're going to use the big formula. We just derived that in our previous video. We're going to use the big formula, and what we're going to do is use it to derive and understand what a cofactor is. So here we go. This is what we said. I need to get my handy tablet glove. So we said that for the determinant, that was a wiggly line. I probably had a bit too much coffee today. It's a beautiful rainy day. Rainy days are designed for doing mathematics and drinking coffee. I just had a little bit too much coffee on this rainy day. But let's keep going. So we said that the big formula for the determinant, which is the sum of, we said it's the determinant of some matrix P, the permutation matrix, times A1 alpha, A2 beta, times all the way out to your last column, which is going to be A2, we can call it, I think we called it omega for the end, where alpha, beta, all the way out to omega is the set of all permutations, the set of all permutations. Now, one way to derive this formula for a 3 by 3 matrix is to use linearity in the same way that we did for a 2 by 2 matrix. Expand it out, you'll get a whole many determinant components that'll just end up being 0, and you can piece it together from that. But what I would like to do today is work directly from the big formula. So that's what we're going to do. This is section 5.2 in our text. It's called Permutations and Cofactors. Permutations and cofactors. And let's apply this. So we're going to find the determinant of A3. So now here's how that formula gets adjusted. What it means is it's going to be the sum of the determinant of P, the sum of the determinant of P times A1 alpha, A2 beta, A3. I think the third letter is gamma, and if it's not, well, it is now. And so what we need is we want the set of all permutations and of alpha, beta, and gamma. Well, what those are, this is the set, this is the permutation of the columns. Well, what are the columns of A? So in other words, alpha would be column 1, beta would be column 2, gamma would be column 3. So if we wanted to write the set of all permutations, well, here we are. Let's write them out. That's going to be 1, 2, 3. And again, let's start with the 1 and switch the 3 and the 2. So it's going to be 1, 3, 2. It's going to be 2. We'll have to start with a 2 now. And let's go in order. So 1, 3, 2, 3, 1. And now we can start with the 3. So that's going to be 3, 1, 2. And our last permutation is 3, 2, 1. Okay. So let's write this out. Well, what this says is, so let's write this begin. The determinant of A3 equals the determinant of P times A. Now look at this. The 1, let me use some blue here. These are always the same. The 1, the 2, and the 3 for the rows are always the same. What's going to change now are the columns. Columns change. So this then becomes A, and we're going to use our first permutation. So that means what I'm going to do then for this very first matrix is I'm going to put this permutation 1, 2, 3 into the column. So that'll be, here's my alpha, beta, gamma. So when I write this, this is A1, here's the first one from the permutation. It's going to be A2 and then the beta, so that's 2, and then A3 and then the gamma, which is also 3, plus the determinant of P. I should have probably put this up higher. That's okay. The determinant of P times A1, but now we use our second permutation. Well, that is this one. So the 1, 3, 2, these are my new alpha, beta, gammas. That first set of alpha, beta, gamma, those are really bad, aren't they? Let me go clean that up so, goodness gracious, you don't have to look at that. I don't want to look at that, so you probably don't either. Okay, that's alpha. Oops. Back to my pen. There's my alpha, beta, gamma. Okay, now let's do this again. So now we have A sub 1, 1. Oops. A sub 1, 1. A2 sub 3. A3 sub 2. Plus the determinant P times, and now we use our next permutation. Our next permutation is this one. It's the 2, 1, 3. So when that's going to be A1, now we use the 2. Then A2, and now we use the 1. Then A3, and now we use that 3, plus the determinant of P, times, now we're going to have A1, and now we use our next permutation, the 2, 3, 1. So we use the 2. And then we have A2, and then we use the 3 from the permutation. And then we have A3, and now we use the 1 from the permutation. Plus, almost there, the determinant, P times A1, and now we go grab our next determinant. That's the 3, 1, 2. So that's going to be determinant of A1, 3. A2, 1, A3, 2, plus the determinant P times A1, and now we're to our final permutation. This is green one here, 3, 2, 1. So A1, 3, then we go A2, and we go to our permutation for another 2, and then we go to our permutation for A3, 1. And that is the formula. Now that looks long. Well, here's what we're going to do. I'm going to, bear with me here, I'm going to copy that. Do my best anyway. Copy. And then I'm going to turn this off. Go here. Paste from my clipboard. And there it is. But I want it right up here at the top. And I'm going to make it even a little smaller. There. Let's put it right up there. Okay, there's my formula. Now we're going to work with this. We are. Because what I want to show you is what each one of these, or one of these terms, for example, might mean. And actually, let me do that on this previous screen. Let me come back, and we'll come back there. So let's take one of these, for example. Let's take, doesn't really matter. Let's take this one here. Yellow. Let's take this. What is this saying? Okay. In the same way that we use linearity to break up a 2 by 2 determinant so that we had independent columns, the result of this is it says this. It's really the determinant of A1, 2. So A1, 2. A2, 1. A2, 1. A3, 3. 3, 3. And these blanks are zeros. Let me put those in. And what it's saying then is that if you were to factor out each one of these components, what you'd be left with is A12 times A21 times A33. But then you'd be left with the determinant of 0, 1, 0, 1, 0, 0, 0, 0, 1. Okay, well, if I do a row exchange, if I make this row exchange with 2 and 1, in other words, if I put this column 1 into the first position and I put column 2 into the second, back into the second position, that was one row exchange. Well, one row exchange, that just gives me A12, A21, A33. That just gives me a -1 times the determinant of the identity. Well, that's just 1, and so what our result is a minus A12, A21, A33. That's what is going on with each one of these terms. That's what the determinant of P is. It has to reorder them back to I. All right, so with that in mind, let's continue back with our big formula here. And let's do this. Here's what I want to do. Let's figure out what all of these determinant of P's for each term are. Look at this. And what you have to do is we have to get to, oh, my pencil isn't working. Wonderful. Oh. There we go. Now, what I have to do is let's figure out each one of these, and I need to get to a permutation in the order of 1, 2, 3, because that is the identity. So in this case, no permutation is needed, so the determinant of P is really the determinant of I, that is 1. And so I have A11, A22, A33. Then let's take a look at this next one. I'm going to rewrite the terms A11, A23, A32. But notice that I'm going to have to permute these two columns, the 3 and the 2. There's one permutation that's going to have to take place. So that means I'm going to have to multiply that by a -1, so minus. Now this next one says, I'm going to write it again, A12, A21, A33. Well, if you're looking at the column indices, so here the third column is in the correct position. It's the second and first columns that need to be switched. So that's one row exchange, which means the determinant of P will be changed by -1. And then let's continue to the third one. So let's see, there's 1, 2, 3. So I'm sorry, we'll continue to the fourth one now. Well, that's going to be A12, A23, A31, A31. Well, this one, let's see, I could move I'm going to have to move the 3 down to here, and then that means the 1 goes up here, but then I have to switch the 1 with the 2, so there's 2 exchanges. 2 exchanges is -1 times -1 times the determinant of I, so that's going to be plus. All right, and then let's see, there's 1, 2, 3, 4. Let's go to the fifth one. The fifth one is A13, A21, A32. Well, let's see, I'm going to have to switch. Ooh, there's a lot of switches here. There's the 1 has to come up to here. That puts the 3 there, but now the 3 has to go back to this column. That's 2 switches again. That's going to give me a plus. And then the final one is A13, A22, A31. Well, let's see. Oh, look, I could just switch the first and third columns, the 2 is where it needs to be. I think we're set. And that would just be one switch, so that's going to give me a minus. Okay, now what I'm going to do is let's factor out, because notice that, let's factor out these row 1 components. In other words, we have an A11 times A22, A33 minus A23, A32. And then let's say I have a minus A12, and then I would have an A21, A33 minus A23, A31, and then let's see, plus an A13 times A21, A32, A32 minus A22, A31. Now, I need to show you where those are coming from. Let's just take a look at A3. So A3 is A11, A12, A2, A13. And it's A21, A22, A23. And it's A31, A32, A33. Well, it doesn't matter if I use a matrix or determinant symbol here. Well, let's just look at what this says. And so I'm going to do that I'm going to do some different colors. I'm going to write on top of that. So notice that the first term, my first term, A11 times this quantity in the parentheses here. Well, that's A11, that's that. And then notice that I have A22, A33. Well, that's this product minus A23, A32. That's, wait a minute. That is just this determinant of this matrix, right? That sub-matrix. We call that the M11 matrix. Okay, that's the M11 matrix. Well, let's continue this this train of thought. And so look at the M11. What that says, it says remove the first row in the first column, and what's left you take the determinant. Okay, so let's write that, and then we're going to do this again. So this is A11 times M11. And now there's another piece that's not so obvious, but I'm going to write it in here. It's times, notice that this is a positive, so it's minus 1 times 1 plus 1. Because notice we're going to have to account for this negative here, and this is where it comes in. Now, let's see here. I'm going to erase that. And let's try again. Let's take a look at this. So A12. So A12 is this one right here. But so if I do follow the same pattern, this A1, the M12 says can't remove row 1, column 2, and then the resulting submatrix would take the determinant. So there it is. Look at this. Let's see if this matches again. Here's A21 times A33 minus the anti-diagonal A23, A31. Oh, look at that. So let's record that as well now. So this is plus, well, normally, yeah, you don't really have to worry about this. It's kind of a mixed bag. You could write, I'm going to write it two different ways. We could just write this as minus A12 times the M12 sub-determinant, or the determinant. I should write determinant around that. Or you can write this as plus, and then write it as a negative 1 to the 1 plus 2. So we'll write it both ways. You'll see in practice it's used both ways. And then it always alternates. Then let's go to our next one. So I'm going to erase this orange. And let's go to another color here. Need this pink. And the pink says, start with A13. That means then remove row 1, column 3. Well, here's my resulting subdeterminant. And notice that this matches up. Here's A21, A32. There's the diagonal part. Minus A22, A31. There's the anti-diagonal component. And so we can write this as plus A13 times the determinant of the submatrix M13 times negative 1 raised to the 1 plus 3. And what this is this is also written as A11 C11 plus A12 C12 plus A13 C13. And this is the cofactor, cofactor form of a determinant. Okay? And that's really what you're going to use if you're going to start calculating some bigger matrices by hand, because they get pretty big pretty fast. So the cofactor matrix or the cofactor formula tends to be the easiest one. And in general, say if you were working this for A sub n, well, the determinant of an, this would be A1 A1j times the cofactor component C1j for j, and is from 1 to n. Okay? That would be the cofactor, and then each C1j is negative 1 raised to the I plus j times the determinant of M1j. That might look difficult. It's actually pretty simple, and I think the best way to see how simple that is with an example in the next video. Hope that helps. Thanks for watching.